Hello and welcome to another tutorial in ANSYS Workbench using SpaceClaim. In this tutorial we are going to look at a combined loading problem, and the combined loading problem will consist of a circular disc on the end of a shaft, a crankshaft that is turned with the hand up here on the handle to lift a 100-pound weight. So the idea is that you will push in the z-axis direction here at point C, and it will rotate this handle, which has this 100 pounds hanging from a cord, and the cord will wrap around this circular disc as it is raised and lowered. The dimensions are given as 10 inches between the bearings and then 5 inches between the handle and this bearing B. This dimension between the horizontal axis here and the handle is 8 inches, and the only load that is applied is this 100-pound load on the end of the disc, as well as two loads of 50 pounds pulling down at point C and 20 pounds pushing in the negative X direction at point C. So we were going to analyze this problem to determine the reaction loads at our bearings A and B, and we're also going to determine where the maximum stresses occur in the shaft. It's important to note that bearing B is a simple radial bearing, where bearing A is a radial thrust bearing and can handle this 20-pound load being applied in the X direction. So we will now start with the tutorial. So after opening ANSYS Workbench 18.1, I come to my static structural, left click, drag it to the project schematic box, move up to the green rectangle, and let go of the mouse button. This will bring up my work list, and I can go ahead and double click on geometry to start SpaceClaim. You can see SpaceClaim is starting. Down here it has a red dot and then SpaceClaim. After SpaceClaim has opened, I can close this dialog window. I can right click, select new sketch plane, and click on the XY plane and look at a plan view of that. I can now go to change my units by going to File, SpaceClaim Options. The default units in SpaceClaim are meters. I want to use inches in this particular problem, so I will go to Units, click on the drop down under Type and click Imperial. The default under Imperial is inches, but the default is also 1/8 of an inch, and I want to go ahead and just use 1/10 of an inch. So I'll type in 0.1, and then it also makes sense to change the number of increments to 10. Now I'm ready to go ahead and start to create my geometry. I'm already in sketch mode, so I can just come and click on the line, and I can start at my origin, and I'm going to build my geometry to the right. So I'll click on my origin, and my first line I'll move along 10 inches. And now you can see that I have my first line drawn. I'm ready to go ahead and create my next line, so I can click and then move this line 10 inches as well. So type in 10. And I now have my two 10-inch lines. I'm ready to go ahead and enter in a 5-inch line. So I will go ahead and click, move this over, and type in 5 inches. And I now have my 5-inch line. I'm ready to go vertical, 5 inches. And even though I'm on 5, I like to type the number in, because sometimes if you don't have enough zeros there, it will not be exactly at 5 inches. So I'll type in 5. Now I'm ready to move this over a little bit, so I'll control click with my roller button, my middle mouse button, and let go to move my design over, and I'll go ahead and type in 5 inches. And I now have the shaft part of my model built, I can go ahead and escape out of this by clicking escape twice. Now I can rotate this around, and I need to move my sketch plane so that I can build the disc. And in this particular model, I'm going to represent the disc with a beam. I'm not focused on the stresses that will occur in the disc. I'm focused on just applying the load that the disc would apply to the shaft. And I'll do that by creating a beam the same length as the radius of the disc. So I will right click, left click sketch new sketch plane. I'll click on the YZ plane. Now I can come back up to my line, click on the origin, and move out here 4 inches, which was the radius of my disc. So I'm now ready to escape out of this twice, and I can go to Design and Prepare. I need to enter in a beam profile or a cross section, so under Prepare I'll hit Profiles. I'm going to make this a circular cross section, and you can see that after doing that, this beam profiles shows up in the structure tree. I can open it up, right click on circle, left click edit beam profile, and I have a circular cross section. I want to change the dimension of that, so I'll left click and then left click on the number, and I'll type in 0.5 inches for the radius of my shaft. Now you can see that after I have done that, this new Sys window comes up, and I want to go back to my design, so I'll click on the Design tab, and then I'll go back to the structure tree, and I'm ready to look at my entire structure now. So I'll go to Design, and if I click on 3D mode, I can see my entire shaft now in 3D mode. To make these curves here turn into beams, I simply need to highlight them. I can do that by box select, and then come over and under Prepare, click on Create, and that has now turned these into beams. If I want to look at the geometry, I can click on Display and then Solid Beams, and that shows me the circular shaft that I have, and I'm ready to start to create this structure so that all of these individual members are connected together. To do that, I need to create a new component, so I'll go to Beams and open it. I need to come back to Design and select. Now I can click on the top member and shift click the bottom beam, right click and say Move to New Component, and I'll call this new component Shaft. Now I need to click on the shaft and come down and change the topology interaction. So under Share Topology, right now nothing's being shared, and I want to merge all of those members together, so I will click to bring up the drop down, then click on Merge, and now all these lines have been merged together and will act as a continuous system. That's all I need to do in SpaceClaim at this point, so I'll go ahead and minimize the SpaceClaim window, double click on Model to bring it up. You can see it's starting mechanical, and when it comes up I'll be ready to continue with my model. So ANSYS Mechanical has now started. It's kind of hard to see your geometry, so I often like to come to open the geometry in the structure tree and click on the geometry, and now with it being shown in green, it's a little bit easier to see the geometry that has been pulled into mechanical. I can go ahead and close this. I don't need to do anything with cross sections, they're already built. My coordinate systems are okay. I'm ready to generate a mesh, so I will right click on Mesh, left click Generate Mesh. And for beam elements, this is probably just fine for mesh density. I'm going to go ahead and open up sizing and click on the relevance center drop down and change it to fine. And now you can see that the grid has, or the mesh has turned yellow, which means changes have been made and an update is required. So I'll come to update, and it updates my mesh with a lot more points or elements, and I'll go ahead and use this mesh. So I'm ready to come to static structural and put in some boundary conditions and some loads. I will right click on static structural, insert displacement, and I'll click on my vertex tab and scroll along my beam until I hit my first node, my first vertex, and I'll go ahead and click on that vertex, click apply, and I'm going to set all of these components to 0. So I simply click on the yellow, enter a 0, and repeat that. So I now have that vertex set in the XYZ to 0. I'm going to go ahead and right click on static structural, insert another displacement, click on my next bearing and apply, and then do the same thing where I enter zeros in. And now I need to look at the boundary condition that I'll put up here on the handle. My applied load out here is going to be 100 in the vertical direction. So to resist that, I'm going to come and put a reaction up here that prevents this point of the handle from moving in the Z direction. So I will go to static structural, right click, insert displacement, click the end of the handle, click apply, and then I will leave all of the X and Y conditions as free, and I'll fix this in the Z dimension. That will let me come and find the reaction at that Z dimension to find out the load that I need to apply to the handle to keep the system in equilibrium. I can now apply the loads. So to apply the loads, I will right click, insert, force. I'll come to this end of this disk, click the point, apply. I'll click on the vector drop down and enter it in as components. I will have a 0x component and a minus 100 in the y component and a 0 in the z. I need to now apply the loads that occur on the handle. So I'll right click on static structural, insert, force, click on the handle, apply, again click the drop down to change it to components. In the X direction I will enter a 0, or excuse me, a minus 20, and in the Y direction I will enter in a minus 50. And those are the loads that will occur out here as prescribed in the definition of the problem. So I can now look at static structural and review my model to make sure I have all the conditions that I need. I can see that I have a displacement here at A, displacement at B, and a third displacement at C, and I have my loads applied. It might be handy to come and change the names of these, so I can click on displacement, right click, and click rename, and I can call this bearing A. I can click on displacement 2, right click, left click rename, call it bearing B, and click, right click, rename, and call this the handle. My forces I can also rename. I can rename this force as disk, and I can rename this force by clicking on it, right click, rename, and handle. Oops. Click enter. So I now have these things named. It probably is helpful to do that. If I want to check any of them, I simply need to click on bearing A, for example, and I can come down and see the conditions that have been set for that particular boundary condition. I want to now enter in the outputs that I'm going to get, so I'll right click on Solution, Insert, and I'm going to insert a beam tool. And now I will right click on Beam Tool, Insert, and click on Beam Tool and click on the deformation. And I'll click on Total Deformation. Now I also want to come to Beam Tool and I want to insert some dimension or some variables such that I can look at my reaction boundary conditions. To do that, I will come to Beam Tool and I can enter in any of these other stresses that I want. To enter in the components so that I can see the reaction loads, I need to come up to Solution, right click, Insert, Probe, and Force Reaction. So I'll do that again, Insert, Probe, Force Reaction. And here in this drop down, I'm going to go ahead and pick bearing A, and I'll enter another force reaction, right click, Insert, Probe, Force Reaction, click the drop down, bearing B. I'll do it one more time for the handle, so right click, Insert, Probe, Force Reaction, and I'll enter in the handle. So I now have those conditions where I'll be able to see my reactions brought into my solution. I also want to look at some other components of the output, so I'll click on Solution, Insert, and on Beam Tool or Beam Results I can come over and click on a shear moment diagram, and this now says that I need to have a path, and I haven't defined a path yet, so I need to come back up to my geometry and design or define a path. So to enter a path, I scroll to the top and right click on the model, Insert, and I'll insert a construction geometry. Now I go to the construction geometry, right click, Insert, and insert a path. Now the default is to generate a path between 2 points. I want to generate a path by using my beam elements or my lines, so I'll click to open the drop down and click Edge. Now I can come and click the first beam, control click the second, control click the third, and under geometry click Apply, and I have now created this path. I could go rename that if I wanted to, but since I only need the one, path will be fine. I can now roll back down to the total shear moment diagram, and under path I can click the drop down and select path, and it goes to all line bodies, and you can see now that I now here have a structure select, the part of the structure selected that I want to look at my shear moment diagram. I need to be careful here. Under type, right now it's going to show me a total shear moment diagram. I want to simply look at the X, Y, and the XZ shear moment diagrams independently, so I'll go ahead and click directional shear moment diagram. Now I need to come back up to Solution, right click, Insert, Beam Results, Shear Moment Diagram, and enter in the same path, but now down here I want to look at the other shear moment diagram about the other axis, so I'll click on that. So that's about all I need to determine the results that I'm looking at. I'll go ahead and begin a solution for this. Right click and solve. So the solve is now complete. I can come and look at my results. The maximum combined stress is shown here. It looks like my maximum stresses occur right here at bearing A. The stresses in the other dimensions or the other locations are not as high. I can look at my force reaction, and my force reaction here says that I have loads of 0 in the X, 160 pounds force in the Y, and minus 80 in the Z. And one thing that I need to be careful with here is I set both of these boundary conditions up here to have a horizontal load carrying capability. And in my model, this bearing B is not a thrust bearing, and so I should probably come back up to bearing B and in the X direction go ahead and down select the drop down and make that free. Now I need to come back and resolve this, so I'll right click and solve. Now after I've obtained this solution, I can come and look at my results again. I can look at my force reaction at bearing A, and I see that I have a 20, a 160, but here I have a minus 80, and my hand calculations show that I should have a minus 50 here. So I have something else wrong with my model that I need to go create or go fix. I can look at the force reaction at B, and this makes sense. I have 0 axial load. This load right here though is also off. So I have something else wrong with my model, and I need to determine what it is. If you look closely here, you can see that this dimension looks about the same as this dimension, whereas in the actual model this vertical direction should be 8 inches. So I can minimize this window and come back to space claim. I can go to measure, click the measure, and I can click on this line, then control click my top line, and I can see that that distance right there is 5 inches where it should be 8 inches. So I need to go ahead and change that and fix that. So I can do that by coming to beams, and I can select this beam and right click, delete, and then I can select this beam, right click and delete. Now I can come back to design, sketch mode, line, and by right click select new grid, I can click this vertical grid again and select it. Now I can come out to this point here, click on it, and move my line up 8 inches. And now I go horizontal 5 inches. And so now I have a different geometry. I can click escape twice and get out of my model. Everything else looks okay there, but I now have these curves that I need to create as beams. Another way I could have done this is just created beams to begin with, and I can do that by coming back to prepare, and here under beams I can now create them along these edges, or I can come back and select these curves. So I can come to select this top curve, control select the vertical curve, and hit create, and I now have beams here. These beams are in a different component or in a different file. I can leave them there, or I can merge them and bring them all into the same graphic. So to turn these lines into beams, I simply need to select them. I can left click, control, left click, and then come to create. And you can see now that I have beams here, and I also have beams in a different component here. In order for all of these beams to talk to each other and be connected, I need to have them in the same component. So what I will do is come in, click the top beam, and control click. You can see that I'm not selecting them as I want to, so I need to come back to design, click on select, click my top beam, control click these other beams, and now I can right click and click move to new component, and I'll call this shaft 2. Now when I look under shaft 2 and look at the beams in there, I have all of the beams of this cross section or of this shaft that I wanted. So I can come up to shaft 2, right click, or excuse me, just left click, come down, look at the shared topology, and again it's none, so I need to click the drop down and click merge. Now I have shaft 2 as my new shaft. I can go ahead and right click or left click on shaft, right click, and delete my original shaft. So now my geometry seems to be a little bit more like I wanted it to be, according to my initial problem statement. So I'll minimize my spaceclaim window, come and open up Design Modeler. Now I need to roll to the top and right click on geometry and click update geometry from source. Now what that has done is it's brought in the new geometry with the 8-inch rise in the handle instead of the 5-inch like it was before. My geometry here is okay, and that's alright. I don't need to redo anything there. My cross sections are okay, but you can see that my construction path has now been changed. So I can go ahead and come to path and now select these other lines. So I can click, control click, and now click apply, and my path has now been updated. Now, I don't need to do anything with coordinate systems. I'll go ahead and right click on mesh and generate mesh. I can scroll down to the sizing, and my relevance center is on fine, and that was already there, and so you can see that it developed or created a fine mesh, which is what I wanted. I need to come and look at my boundary conditions, and for my bearing A I can click on bearing A and it says no selection, so I'll come back up to select the vertex selector, scroll along my geometry till I find bearing A, click on it, click on apply. Now I can click on bearing B, roll along until I hit bearing B, click on it and click apply. Now I can click on my handle. I can roll along on my handle till I hit the end of my handle, click and apply. And the nice thing about this is I don't have to go back and redo all of these boundary conditions. I just need to identify the new geometry that is associated with the boundary conditions that I already had. Now to do my force, I click on my disk. My force up here is going to be a little bit hard to see, so I can scroll that around, pick my point. There's my selection, and the same force was applied. I can come to my handle loads, pick my endpoint here, and click apply. Now I have my updated model. I have my new, or my same boundary conditions and loads that I had before, and everything is green checked here, but I'm ready. I have lightning bolts, which means this is ready to be solved, so I'll right click and click solve. So after I've obtained a solution, I have my green check marks, I can come to force reaction, and this is the reaction forces at bearing A. If I roll down, I can see that in the X it's 20 pounds, 166 in the Y, and minus 50 pounds in the Z. These are the exact same values that I obtained by my hand calculations. Now I can look at the reactions at bearing B and roll down, and I see that these are the exact same boundary or reaction values that I had on my bearing at B. And finally I can look at the reaction that is needed to hold the 100 pounds up at the 4-inch radius, and I can see that that is 50 pounds in the minus Z direction, and that is the load that would compensate for the twisting in the shaft. I can now come and look at my shear moment diagrams, and my shear moment diagram for my first one in the XY plane looks just like I have in my hand calculation analysis. I have a constant load, then these point loads, and I have my moment and then my deflection. I can look at the shear moment diagram about the other axis, the XZ axis, and I go along 0, then jump up, and again this shear moment diagram looks just like the results that I obtained from my hand calculations. So this gives you an idea of how to use ANSYS Workbench to solve combined loading problems. I hope this has been helpful to you.